In this lesson, I'll show you how to find the original equation of a second derivative using integrals. The question reads, find the equation that has a second derivative, y double prime is equal to 4x minus 2, and that has a slope of 1 at the point 2 and 9. What we have to do here is first go from the second derivative to the first derivative, and we can do that by finding the integral of 4x minus 2. So the first derivative, y prime, is equal to the integral of 4x minus 2. By finding the integral, we're technically finding the first derivative, which we can then substitute our slope into, which is our rate of change, at 2 to find the missing constant. If you didn't catch that, let's start with the first step, which is to find the integral. It's not hard to do. The integral of 4x is, well, I'll show my work here. 4x becomes 4x to the power of 2 over 2. So you take the sum of this, you first add 1 to the exponent, you take its sum and divide it by 2, and you should end up with 2x to the power of 2. This term has become 2x to the power of 2, and this term has become negative 2x plus c. We're told the slope is 1, so our y prime is 1. You can even represent your y prime as dy over dx, and that is the rate of change, 1, the slope. That happens at the point 2 and 9. Therefore, in order to have gotten 1, we had to have placed 2 into the x's. And from that, we can solve for c. Here's what I mean. 1 is equal to 2 times 2 to the power of 2 minus 2 times 2 plus c. 2 times 4 is 8 minus 4. 8 minus 4 plus c. Solving for c, we subtract these two. That gives us 4. Bringing that positive 4 to the left side, we get 1 minus 4 is equal to c, and that's negative 3. Therefore, our first derivative was y prime is equal to 2x squared minus 2x minus 3. We still need to do this one more time. So I'll take the integral of 2x squared minus 2x minus 3, and then once again I'll substitute 2 and 9 into that to find out my constant, and that will give me my original equation. The integral of 2x to the power of 2, increase that by 1, that gives us 3 divided by 3. Increase this 1 by 1, and then divide the whole thing by 2, that gives us simply x to the power of 2. And this becomes negative 3x plus our arbitrary constant c. Now what we can do is substitute the points 2 and 9 into our x and our y, and we can find out what our constant is, our original constant. 2 to the power of 3 is 8 times 2 is 16 divided by 3, that's 16 divided by 3. 2 to the power of 2 is 4. Negative 3 times 2 is negative 6 plus c is equal to 9. Now all I have to do is simplify these three terms and solve for c. Using my calculator, 16 divided by 3 minus 4 minus 6. Bringing this now over makes it positive, so 9 plus 14 over 3 gives me 41 over 3. 41 over 3 is my original constant, giving me an original equation of y is equal to 2x to the power of 3 over 3 minus x squared minus 3x plus 41 over 3. And so there you have it. That is how to find the original equation of a second derivative using integrals.